0. Hello everybody, this is Milosoft, and today we're going to take a look at cracking Operation Wolf by Ocean. This is the PAL version in G64 format, and we're going to load it into DIR master. And the reason we're going to do that is to see if there's any disk errors. So we go View, the BAM editor. BAM is short for Block Allocation Map. It's a table of contents for the disk. It's found on track 18, sector 0, and it's an index of which sectors are used and which sectors aren't. You can see here we have 20 sectors, 35 tracks. These ones are in use. These ones aren't. If you take a look at track 22, sector 10, you can see that there's an error 23. That's of interest. Track 22, sector 10. Let's load the game and see what happens. There's the title picture. And there's the game. If we look at the contents of the disk using CCS emulator, there's a loader file, there's a file named F, there's the code, and then there's the loading picture. The protection is most likely going to be here, because the loader is just one block. This is the loading picture. It could be in here. This is 254 blocks, so this is basically the entirety of the 64's memory. But let's try F and see what happens. There's nothing there. So we want to find out where this file starts and ends. If you have a cartridge, it could tell you where the file begins and ends when it loads. I'm just going to make a quick program here. I'm not using a real 64, so I'm making a few errors here. There we go. So the first line opens a channel 2 for device 8. It reads the program F. The comma P means program, and comma R means read. We're going to get the first 2 bytes and put it into A string and B string, and then we print the ASCII value of A string plus 256 times B string. And the reason we do that is A string is the low byte and B string is the high byte, so we multiply the high byte by 256. So we know that the program F starts at 47616, which is BA00. If you want to find out the ending address, you can also look at 2D and 2E, which points to the end of the file. So it ends at BDBA. You might have a cartridge that tells you where the file starts and ends when you load it, which would be great. In my case, I don't have that. So we're going to take a look at A1000, and you can see that this is Commodore Basic. And you look at B800, doesn't stand out as being a loader. The reason for that is we have to switch out the ROM and make it RAM. because A1000 to BFFF is the basic kernel. So we have to switch that out and make it into RAM. And you can see now that Commodore Basic is gone. And there is the loader. And I did that by typing in bank 0. In Vice Emulator, you would probably go to location 1 and change it to a 34. I'm not quite familiar with how you do it in Vice. Now, what we see here is it's calling FFBD. FFBD is the file name. A is the length, and X and Y are the pointer. So we know the length of the file is 3, and it's pointing to BA86. So let's take a look at BA86. We know it's 3 characters long, so it's I0 colon. It's loading A with 15, transferring A to Y, loading X with 8, calling FFBA. FFBA is set file parameters. So your logical number, your secondary address, and the device in X. So it's effectively doing this. Open 15, 8, 15, comma, I0, and a colon. And then it's sending the command. So it just initializes the drive. We go down to BA21. It opens 2, 8, 2 at FFBA. FFBA set file parameters. And if you look here, again, we're calling FFBD, which is the file name. It's a 1-character file name at BA89. And that happens to be the number sign. So this is basically doing 2, 8, 2, it's opening a buffer. Here, it's loading X with 0, loading at what is at BA8A, which happens to be U1 colon 2, 0, 22, 10, which just happens to be track 22, sector 10 that had the disk error on it. It sends it to FFA8, which is write byte to serial bus. It increments X, branch is not equal, goes right back up here. And because we incremented X, it now sends the 1 and the colon and the 2, 0 until it hits the 0. And then when it loads BA8A, X, and it's here, because it's a 0, it branch equals down to here. So we're reading the sector 20, track 22, sector 10. And then here at BA55, we're loading X with 15, JSR FFC6, which happens to be define file as default input. So normally FFE4 reads a byte from the keyboard. It's to check if the user has pressed a key. But because we've set X to 15 and called FFC6, FFC6, X equals logical number. We're actually reading a byte from the error channel, from channel 15 of the disk drive. So just to recap what we've done, it sent the I0 colon command. It's opened a buffer. It has sent the U1 command to read the sector. And then here, it's reading the error channel. It's just getting 1 byte, pushing it to the stack, calling FFCC, which is close the input-output files. It pulls it back from the stack, compares it to a 13 if it's equal to 13. Go back up and keep fetching from the error channel. And then it checks to see if it found a 32. 32 just happens to be a 2, which would be part of the 23 read error. Let's put this into perspective. This is exactly what it's doing in BASIC. .23 read error. So the first byte is a 2 because that tracking sector has an error on it. I know I'm probably going a little quickly for you. So it's checking to see if it has found an error that starts with a 2, as in 23. If it's not equal to a 2, meaning it's not the original disk, it goes down to BA71, puts a 37 in BA98, and jumps to 150. There's nothing at 150, so it crashes. If it is the original disk, and it has the 23 error on it, when it compares to see if it's a 32, which is ASCII for 2, it's going to be equal, so it's going to go down here, set BA98 to 30, branch not equal. It's not equal to 0, so it goes down, it skips the crash and goes to BA79. So if we want to crack the game, we just have to change this check right here. So let's have a look at how to do that. There are a few ways we could do it. We could take this out. We could change this. We could change this to a 30 to see if it's a 0, meaning 0, okay, there's no error. But if you had to put in the copy protected disk, it would crash because it would be a 32. I'm sorry, a 23. That's with the error. Without the error, it's 0, okay. So let me just think of the best way to do this here. What we're going to do is we're just going to change these 2 bytes right here. EA, EA. So currently, if it's not equal to 32, meaning it doesn't find the 2, it goes down here and crashes. So we're just going to change it. We're going to put EA, EA, press return. We're going to take a look at it. So now it checks to see if it's a 32. It does absolutely nothing, no operation, no operation, and falls through, loading the accumulator with 30, storing it in BA98. Because it's not equal to a 0, it goes down to BA79 and skips the crash and continues. So what we're going to do is we're going to save. We're going to call it F2 instead of F. Start address is BA00. The end address is BDBA. Now, if you were using the Vice emulator, you could save this right to the D64 image. I'm not sure how you do it in CCS64. I'm just going to kind of use a roundabout way of doing it. So I have saved it. I'm going to load Operation Wolf. And I am going to delete the old F file. I'm then going to go File, Import. From my CCS folder, F2. It's in capitals, so I need to rename it to just F. I'm going to save, and we'll call it V1, version 1. Now, version 1 still has the disk error. So what I'm going to do is I'm going to make a new disk. And we're going to copy everything over. Close that out. And save it as cracked copy. Now comes the true test. Cracked copy. Let's give it a shot. It's loading. I'm going to speed it up a bit. There's the title picture. There's the game. And just to confirm, view BAM, there are no disk errors. So we have cracked it. Switch out the ROM, take a look at BA100. Okay, the game's loaded, so it's been overwritten, but yeah, there you go. You have now cracked your copy of Operation Wolf. This is Milosoft saying, take care.